In this video, we will learn how to find minimum value of a cost function, and second question will be to find the level of output where total revenue will be maximum from the demand function. Okay. So the first question is determine the minimum value of cost function c is equal to x square minus 4x plus 10x denotes the output. Okay. So given this total cost function, let us draw the graph to make it more sense. So we have x on the horizontal axis, which denotes the output, and total cost on the vertical axis. Okay. So if we plot this equation, it will look like this. Okay, so this is our cost function. We need to find the minimum value of this cost function. Okay, so to find the minimum value, there are two conditions. First condition is, so first order condition for minimum or maximum is simple. The derivative of cost function should be equal to 0. Okay, that means the first derivative of cost function with respect to output should be equal to 0. This is our first this is our cost function taking derivative with respect to x. Okay, so derivative of x square is 2x minus derivative of x here is 1, so we are left to minus 4, and we set it equal to 0. Okay, solving for x, that means x will be equal to 4. Sorry, x will be equal to 2 because 4 upon 2 is 2. Okay, this is first order condition. So when output level is equal to 2, slope of the cost function is equal to 0. Okay, when we say first derivative of cost function is equal to 0, what exactly we mean? We mean the marginal cost should be equal to 0. Okay, so the first derivative of cost function gives us marginal cost. Okay, so we found out the minimum value where cost is minimum. Okay, minimum value of the cost function is 2, but this is only first order condition. We need to check out the second order condition only. Okay, second order condition also. Why? We can have a graph like this at times. Okay, so here there are 2 points where slope is equal to 0. Here it is 1 point, and here also the slope is equal to 0. Now to really differentiate between the maximum point and minimum point, we need to check second order condition. Okay, so second order condition is used to check whether we are at minimum or maximum. Okay, so first order condition was applied to find out the slope equal to 0. Now second order condition will require, second order condition tells us whether we are at minimum or maximum. If we are minimum, then the second order derivative, that is d square c upon dx square, when evaluating that at the critical point, should be greater than 0. Okay, if we are at minimum. For maximum, the second order derivative d square c upon dx square, when evaluating at this critical point, should be less than 0. Okay, that means the slope should be increasing when reaching to the this point, when the slope is equal to 0. Here the slope should be decreasing when reaching to the point where slope is equal to 0. Okay, so let's take the second order derivative. So this is our dc upon dx. Second order derivative means, and let's write it here. Second order derivative means dc, or let's write it d square c upon dx square, evaluating at the critical point x is equal to 2. Okay, so what is second order derivative? Derivative of this function. This is first derivative. Taking derivative of this first derivative gives us the second derivative. Derivative of x is 1, so we are left with only 2. Here we can see we got only 2, which is greater than 0. That means we are obviously at the minimum point. Okay, so this will be our minimum point. Okay, it is used to make sure that we are at minimum. First order condition tells us the slope should be equal to 0, and second order condition tells us whether we are at minimum or maximum. If we are at minimum, then the second order, okay, the second order derivative okay, should be less than 0. If we are at maximum, second order derivative should be greater than 0. Okay, so this was the first part. Let's come to the second part. Okay, so the second part tells us, if the demand function is being given as p is equal to 9 minus x under root, find the level of output where total revenue will be maximum, and to find out the corresponding maximum revenue. Let's write the demand function, that is p is equal to, under root can be written as, we have 9 minus x 1 upon 2. Okay, okay, simple thing. So first we need to find out the total revenue, and total revenue we know is nothing but price into output. Okay, so that means total revenue will be equal to, price function is 9 minus x raised power 1 upon 2 times x. Okay, so if we draw the graph of this function, we have x on this side, output on the horizontal axis, and total revenue on the vertical axis. Its graph will look like this. Okay, this is total revenue function. We need to find the level of output where total revenue will be maximum. Okay, again we need to find the slope, the point where slope will be equal to 0. Okay, so first order condition requires, first order condition for minimum or maximum is same. That means the derivative of total revenue function with respect to output should be equal to 0. This is the first condition. Now derivative of total revenue function with respect to output is actually a condition, what we call is a term which is, that means the first derivative of total revenue function is obviously marginal revenue, it should be equal to 0. Okay, now here you can see we cannot directly apply the, you know, differentiation. Okay, we need to apply a rule, what we call the product rule here. Okay, what exactly is the product rule? Let me write it here. We have 9 minus x raised power 1 upon 2. Okay, I'm just trying to make it useful, times x. Actually we have two functions here. Let us say this is f of x, let us denote it by g of x. Okay, let us say it is hx. That means hx is a function of two functions, that is fx times gx, and in place of hx we have actually this total revenue. Okay, total revenue is a function of two functions. Now how do we apply product rule? Simple thing, let us denote h dash x for the sake of simplicity. That means h dash x is the first derivative. Okay, then the first derivative of this function will be equal to, we write the first function as it is, f of x, take the multiply and take the derivative of second function which is gx, its derivative let's denote it by g dash x. Then we write the second function as it is, gx, and take derivative of first function which is f dash x. Okay, and here we apply the same stuff. That means dtr upon dx will be equal to, so in place of fx we have 9 minus x, we write it as it is 9 minus x raised power 1 upon 2. Then take derivative of second function. Second function is x, derivative of x is 1, so let's write it here 1. Then we write plus, we write the second function as it is, so second function is x. Then we take the derivative of first function. So first for f dash x means taking derivative of first function. We have 9 minus x raised power 1 upon 2. Its derivative is simply by power function rule, exponent becomes coefficient. We have 1 upon 2 9 minus x, and exponent is subtracted by 1, so 1 upon 2 minus 1 becomes minus 1 upon 2. Then we need to apply this chain rule. Okay, so whatever is in the brackets we need to differentiate that very stuff. Okay, derivative of a constant is 0, derivative of x is 1, so we are left with minus 1. Okay, so then we multiply that very derivative. Okay, first we take the power function rule, then we internally differentiate. Okay, whatever is in the brackets we differentiate that and multiply. Okay, so we get here 1 upon 2 9 minus x raised power minus 1 upon 2 times minus 1, and it should be equal to 0 obviously. Let me rub this out now. Okay, let us rewrite it and solve it. That means we got 9 minus x raised power 1 upon 2 plus x divided by 2. Okay, if I actually we have plus into minus is minus, so minus x upon 2. If I transpose this, exponent sign will get changed. We will get 9 minus x raised power plus 1 upon 2 should be equal to 0. So cross multiplying, so we have 2, then we have 9 minus x raised power 1 upon 2 times 9 minus x raised power 1 upon 2. This step 9 minus x raised power 1 upon 2 times 9 minus x raised power 1 upon 2. We have the same basis. We can add up the exponent. So in place of 2, 9 minus x, we can write the common 9 minus x and add up the exponent. Simple, mathematics here. So 9 minus x we get because or to or go ak. Okay, this adds up to 1. So we can write 2 9 minus x, then we have minus 1 should be equal to 0, and here we have 2 9 minus x raised power 1 upon 2. Okay, solving it. So we have 2 nines are 18, so we get 18 minus 2x. Here we have actually x. Okay, then we get minus x should be equal to, when I transpose it here, multiply with 0, it will get become 0. A simple thing. So this is 18 minus 3x is equal to 0, or 3x is equal to 18, or x comes out to be 18 divided by 3 is 6. That means the level of output where total revenue will be maximum will be equal to 6.